Welcome back to this channel where I present solutions of practice problems for professional actuarial exams. Here are some links where you can find information about the program that I run at Illinois State University, about me. I'm the program director, so I'm not the only person working at Illinois State University. We have an excellent program and you should study with us. And if you want to help out our program, go to smarturl.it/help ISU actuary. I have used consistently this redirect service smarturl.it, so you can find, for example, my advice on how to pass actuarial exams at smarturl.it/pass. And this YouTube channel is at smarturl.it/pass actuarial exams. This is a problem from Spring 2017 exam MLC, multiple choice section problem number 4, and it's about the following Markov model, the Markov process. It's a discrete Markov process in this case. Annual transition probabilities are as follows. So there are 3 states: healthy, sick, and terminated. And there are probabilities of transition. So from healthy to healthy, for example, 0.90, from healthy to sick, 0.05, from healthy to terminated, 0.05, and so on. The annual healthcare costs each year payable at the middle of the year for each state are, for a healthy person, 500, for a sick person, 5,000, terminated, nothing. Transitions occur at the end of the year. Force of interest delta is 0.04. Calculate the actual present value of healthcare costs over the next 3 years for an individual who is currently healthy. So this information that we had in the transition probabilities, it's basically transition metrics. And there are 3 states: healthy, sick, and terminated. And their transition probabilities are in the transition matrix. At time 0, the person is known to be in state of being healthy, so the first of the 3 states, with probability 1, we can say, and then with probability 0 in other states, that it makes the state vector to be 1, 0, 0 at time 0. At time 1, it becomes, well, you get that state vector by simply multiplying the state vector at time 0 times the transition matrix, which amounts to multiplying that row vector 1, 0, 0 by the first column. So 1 times 0.90 plus 0 times 0.30 plus 0 times 0 to get 0.90 as the first entry in the state vector for time 1. And then for second column, 1 times 0.05, 0 times 0.06, 0 times 0, so that's 0.05. And then the third column, 1 times 0.05, 0 times 0.10, and 0 times 1, that gives us 0.05. That's the third entry in the state vector at time 1. So these are the probabilities of being in various states at time 1 for this person: 0.90, 0.05, 0.05. Then at time 2, there's another transition, and we multiply that state vector by the matrix, by the transition matrix. And we get the probabilities of being in the 3 states at time 2. So again, we multiply the row vector times the first column. 0.9 times 0.9 is 0.81. 0.05 times 0.3 is 0.015. So we add the 2 and we get 0.825. And then the row vector times the second column gives us 0.075. So 0.90 times 0.05 plus 0.05 times 0.60 plus 0.05 times 0. That's 0.075. And then the state vector multiplied by the third column, and it's a dot product of the 2 vectors. You can think about it as a dot product of 2 vectors. That works just the same way. So it's 0.9 times 0.05 plus 0.05 times 0.1. Well, that actually you can immediately see that that's going to be 0.10, because what's 0.90 plus 0.10? That's 1. And so 1 times 0.05 we get from the first two, and then 0.05 times 1 from the third one, so 0.05 plus 0.05, 0.10. And we don't do the calculation of state vector at time 3. It doesn't enter into consideration because the costs resulting from it will be paid after time 3, and we are calculating the cost over the next 3 years only, right? Three years. So what happens after time 3 doesn't matter. The actuarial present value of healthcare costs over the next 3 years for an individual who is currently healthy, then it's simply calculated from those state vectors based on their probabilities and the costs corresponding. So in year 1, we are in state of being healthy with probability 1. The cost is paid in the middle of the year, so we have 500 paid with probability 1 at time 0.5. We discount it back, and the force of interest is 0.04. That's how this is calculated. At time, for year 2, the costs are paid at time 1.5, and we have them either for a state of being healthy of 500 and the probability of that is 0.90, or a state of being sick, the probability of that is 0.05, the cost is 5,000. And notice that in both cases, the force of interest is 0.04 per year, but the payments for the second year are made at time 1.5. That's why we discount by multiplying by e to the minus 1.5 times 0.04. 1.5 is the time when it happens, and 0.04 is the force of interest. And then for year 3, the probability of being healthy is 0.825, and the cost is 500, and then the payment is at time 2.5 with discount, and the force of interest is 0.04, and then the probability of being sick is 0.075. The amount paid is 5,000 at time 2.5, discounted at the force of interest of 0.04. So it's a little bit of calculation, but you can do this. And then the number that comes out is 1861.89 approximately. That's answer D, and that's a complete solution. Please remember this is copyrighted material, and please remember also that the actual problems from past Society of Actuaries examinations belong to the Society of Actuaries. Are used with permission. You should always ask Society of Actuaries if you want to use their problem in some way. And I do wish you good luck in your studying and on the exam.